All right, guys. So let's finish this up. What we got to talk about is energy from fatty acid. So we're going to look at the breakdown of stearic acid over here. All right. Before we get going on that, for glucose, we get 32 ATP for every 1 mole of glucose. And there's 180 grams in 1 mole of glucose. And so we get 0.18 moles of ATP per gram of glucose. Now, for stearic acid, which is a triacylglycerol, you see we get 0.42 moles of ATP for every gram of stearic acid. So we get over 2 times as much energy from fats. And here we go. So stearic acid, we have our breakdown. Um, One of the things about this that we have to remember, and this is key, is to kickstart digestion of fats, fatty acids, you have to input 2 ATP. That's why I'm putting this minus 2 ATP right there. You put in 2 ATP to get this whole process going. Then we add up ATP from beta oxidation. We have 8 NADHs, and there's 2.5 ATP per NADH. We get 20 ATP from there. We get 8 FADH2s, and we get 1.5 ATP from that. We get 12 here. Add up ATP from acetyl-CoA, so we get 9 acetyl-CoAs, and we get 10 ATP from every acetyl-CoA. That's 90. Now we're just going to add it up. -2 plus 20 plus 12 plus 90 gives us 120 ATP from 1 mole of stearic acid. Now, as we do lauric acid, this is a little different. It's what we did before. To start, we always have -2, all right? Now, from the NADH, what we had, because there were 7 cycles, I believe it was 7 cycles, um, we have this, all right? Well, maybe not. Lauric acid isn't that big. Anyways, if we did lauric acid, this is our start. This is how many NADHs. This is how many FADHs, all right? And this is how many acetyl-CoAs. So if we have 10 ATP for every acetyl-CoA, here there's 6 acetyl-CoAs. And so this is what we get. When we add it all up, we get 78 ATP. Think about bears hibernating. They go into hibernation, they have a big fatty hump. They utilize those fats for energy. Moved on. So ketosis, this is a big deal right now. Everybody's talking about the keto diet. Ketone bodies are formed when acetyl-CoA exceeds capacity for the citric acid cycle. It occurs under these things like starvation, stringent dieting, or diabetes. Um, Glucose is not available to pass in the cell as fuel. Ketones are then eliminated in urine, and so that's how you test if you're in ketosis or not. You test urine. Now, ketoacidosis is something that crops up when you have a lot of ketones. You lower the blood pH. That means it's acidic. All right. So that's ketosis. Now, one of the things about ketosis that has cropped up is people that suffer from seizures. They're finding that the keto diet is a viable option. There's scientific research to back it up, and the number of seizures that people have goes down by a marked amount. So it is useful for people with certain conditions. Um, we're going to jump to 20. Well, we'll look at this for a moment. Amino acid metabolism. We have amino acids, amino acid catabolism. We get the ammonium ion kicked out during the urea cycle. The carbon skeleton, we get pyruvate, acetyl-CoA, and dumped in the citric acid cycle. But essentially, what you could say is this: what happens to nitrogen atoms? Boom, they get kicked out as ammonia. What happens to carbon atoms? Well, they keep going down, and the carbon skeleton is either turned into pyruvate, acetyl-CoA, or they're just dumped into the citric acid cycle.